Let's discuss further mensuration. And in that further mensuration, we'll be discussing about arcs, sectors, and segments. The first question we want to take there is this question. It says, a circular arc of a circle, radius 24 centimeters, subtends an angle of 150 degrees to the center of the circle. We should calculate A, the perimeter of the sector, B, the area of the sector. Let's assume that this is the circle. I have to manage whatever I draw, the way I draw it. You can see it dancing, but it doesn't matter. Pay attention to the illustration I want to see from it. Let this be the center of the circle. So they said the arc subtends an angle 150. So let's assume that this is the angle. Let this be the angle 150 degrees. Now, question number A says that we should find the perimeter of the sector. This is now the sector. This time from here to here, back to this place and here. So if we name this O and this A and this B, the sector is OAB. And the perimeter of that sector is the distance from here to here, the arc, and back to this place. Remember, the question says that the radius of this circle is 24 centimeters. That means this place also is 24 centimeters. But because both of them, AO and BO, are all the radius of the circle. So first of all, let's calculate the length of the arc. When we calculate the length of the arc, we add it to twice the radius of the circle. It will give us the perimeter. Arc OAB. Its length will be given by this formula, theta all over 360 times 2 pi R. This theta is the angle the arc subtends to the center, and in this case our theta is 150. So we have 150 divided by 360 times 2 all over 1 times pi has a standard figure or a standard value, which is 22 all over 7, times the radius has been given in the question, which is 24 divided by 1. If we solve this with our calculator, we discover that it will give us the length of this arc, giving me 158,400. It's going to be all over 360 times 7, 2,520. 2,520. If you divide out this, whatever it gives you is the length of that arc. It's giving me 62.857 centimeters. Now this is the length of the arc. The perimeter which the question actually has asked for will come by adding this length of the arc plus twice the radius of the circle. That means 2 times the radius, which is 24, then plus the arc length, which is 62.857, will give you the perimeter. Two times 4 is 8. 2 times 2 is 4. So we have 48 plus 62.857 is giving us the perimeter. So let's add 48 plus 62.857 is giving me 110.857 centimeters, and that is the length of the perimeter, which question number A has asked for. Then question number B, let me manage the space for it. So we to calculate the area of the sector. Area of a sector is calculated from the formula theta over 360 times pi r squared. Our theta is 150 divided by 360 times 22 over 7, the value of pi, times 24 squared r, which is the radius of the circle, all over 1. Start from here. 24 times 24 is giving us this value, then times 22 is giving us this value, times 150. What you have here is 1,900,800 divided by 360 times 7 will give you 2520. Exactly what we got here by multiplying this. Now divide out 19,008,000 divided by 2520 is giving me 754.286 centimeters squared. This answer, I rounded it up to 3 decimal places, and that has brought us to the end of that question. Question number 2 says that a pendulum is 105 centimeters long and it swings about one end through 5 degrees on either side of the vertical. If one complete swing takes 2 seconds, calculate A, the angle through which it swings in a complete swing. B, how far the tip of the pendulum moves in 1 hour. I hope you know what a pendulum is. It is better explained in physics. A pendulum is a rope that one end of it, a ball is tied, a metal ball is tied. Then the other end of the rope will be suspended by a clip. Then that ball at the end of the rope will be thrusted through an angle from the vertical. Then allowed, it will be dangling to go to, fro, flow. We call it pendulum. So the pendulum takes this shape. Don't mind my drawing. I'm not a good artist too, but I can draw and explain something. Pendulum is something like this. A rope suspended with a clip. At the end of the rope, you have a ball, and this ball will be thrusted through an angle. So, if this is the pendulum the question is talking about, it said it swings about one end through 5 degrees. That means when it is thrusted through an angle of 5 degrees. This angle here is 5 degrees. And it will also swing through an angle of another 5 degrees in this side. This is also another 5 degrees. Now, if this is the case, yes, through 5 degrees on either side of the vertical. This is the vertical. On both the right and the left side of the vertical, it swings through 5 degrees. That's what it means. Then, if one complete swing takes 2 seconds, then we should calculate all these things. The first thing we are asked to calculate is the angle through which it swings in a complete swing. Okay. Now, let me tell you what a complete swing of a pendulum is. A complete swing is when this pendulum moves to this side. Let's call this place O. Let's call this place B. And let's call this place A. If this pendulum should move from here to here, B, come back to O, go to A, and come back to O. That is where it has made a complete swing. 1, 2, 3, and come back to where it started from. That is a complete swing. The complete swing will take from here to here, from O to B, plus from B back to O, plus from O to A, then plus from A back to O. From O to B is 5 degrees. B back to O is another 5 degrees. O to A is another 5 degrees. And A back to O is another 5 degrees. That means we have 1, 2, 3, 4 times 5, which will give us 20. That means there is 20 degrees in one complete swing. Let's take question B. He said we should calculate how far the tip of the pendulum moves in 1 hour. Okay. Take for instance, let's clean up this ball. Naturally, the ball, when it is moving, it makes an arc. It makes an arc in this form. Then this arc should now answer OB. The length of this arc times 4 is the length of an arc that is covered in 2 seconds. That is the complete swing. So we are going to calculate the length of this arc OB. Multiply it by 4. It will give us the length of the arc that is covered in 2 seconds. Then we now use that to now find the length of the arc, or the distance that will be covered in 1 hour. Arc length is calculated from this formula: theta all over 360 times 2 pi r. In this case now, our theta is 5 degrees. So we're going to have 5 all over 360 times 2 all over 1 times pi is 22 all over 7 times r. The r that we're going to use here is the length of the perpendicular, which was given to be 105 centimeters. So we have 105 all over 1. If we multiply out, we find the length of this arc. It's giving me 23,100. Now divided by 360 times 7 is 2520. You should memorize something like that because you always have it in this kind of concept. Now divide out 23,100 divided by 2520 is equal to, giving me approximately 9.2 centimeters. This is the length of this arc OB. Remember, the complete swing is arc OB times 4, because 1, 2, 3 and back to 4. So multiply this by 4. 9.2 times 4 will give us 36.8 centimeters. That is the length of the arc that is covered in 2 seconds. I hope you're following us. We have to clean up this so that we can continue. Now, if 2 seconds will give 36.8 centimeters, what of 1 hour? 1 hour is 60 times 60 seconds. I hope you know. 60 times 60 seconds will be, or will give 60 times 60 seconds divided by 2 times 36.8 all over 1 centimeters. Let's multiply out and divide. It's given me 132,480. Then divided by 2, giving me 66,240 centimeters. So that is the far the pendulum will go in 1 hour. 66,240 centimeters. This is question number 3. The question says, assuming the figure above, this figure, is a tunnel that has the shape of a segment of a circle of diameter 4 meters. We are asked to find AB, the distance AB, B, the perimeter of ALB. Perimeter of ALB. You know what a tunnel is? A tunnel is maybe a hole through which you can pass through a substance or through an obstacle. Any hole that if you follow it, you get to the other side of an event is called a tunnel. So take this as if it is a tunnel, but the ground here cuts off what is supposed to be the round shape of the tunnel. This O here signifies that this place is the center of the supposed circle. These two bars you have on these sides means that this side is equal to this side and is equal to this side. With this information in our mind, let's go. They say we should calculate AB. If you look at this now, this is a right-angled triangle. A right-angled triangle. And if that is a right-angled triangle, OB is the hypotenuse, BM is one of the sides, and OM is the other side. Now, in Pythagoras, or the Pythagoras theorem, tells us that the square of the hypotenuse is equal to the sum of the square of the other sides of the right angle triangle. What I mean is that by Pythagoras theorem, OB squared, OB squared is equal to BM squared plus MO squared. Pythagoras theorem. If the question gave us that the diameter of the circle is 4 meters, that means OB, which is the radius, will be half of the diameter. Half of the diameter will now be 2 meters. So we have, instead of OB, let's use 2 squared to replace it. It's equal to BM squared plus MO squared. BM squared plus MO squared. But by the reason of these two strokes on BM and MO, it means that BM is equal to MO. That means what we have here is BM squared plus BM squared, because BM is equal to MO. That means now that 4, 2 squared, 2 times 2 is equal to 2 BM squared. Mathematically, 4 divided by 2, if you want to divide both sides of the equation by 2 to eliminate this 2 in front of BM squared, will now be equal to BM squared. 2, 4 divided by 2 is 2. Is now BM squared. If BM squared is 2, that means the square root of 2 is equal to ordinary BM. And what is the square root of 2? 1.414. That means BM is now equal to 1.4142 in 4 decimal places. Now, if BM is 1.4142 meters, that means AB, which the question is asking after, will be 2 times 1.4142, because BM is equal to AM, and AM plus MB or BM is equal to AB. So our AB will be equal to 2 times 1.4142 meters. And it's going to give us 2 times 2 is 4. 2 times 4 is 8. 2 times 1 is 2. 2 times 4 is 8. Good point. 2 times 1 is 2. So it's giving us 2.8284 meters. Now question number B. Question B. Remember, this is question A. Question B said we should find the perimeter of ALB. ALB. Part of the circle. That is this arc. ALB. Arc length is calculated by the formula theta over 360 times 2 pi r. In this case, what is going to be our theta? The theta is going to be the angle, the reflex angle which this arc ALB sustains to the center O. And that is the one that I have drawn here. Not this, but this one. We call it the reflex angle that is sustained to the center of the circle. Now, how do we calculate that reflex angle? If you look close here, you discover that triangle OMB is an isosceles triangle. And it is not only an isosceles triangle, it is a right-angled isosceles triangle. Why do I say that? These two strokes on this side tells us that this side MB is equal to MO. And it is right angled here. For any right angled isosceles triangle, the base angles are always equal and equal to 45 degrees. Why is it like that? You know that the sum of the three angles of any triangle on earth is 180. Already you have one of the angles measuring 90 degrees. If you remove 90 from 80, you'll be left with 90, isn't it? Good. Now, the base angles of any isosceles triangle on earth is equal to themselves. So if this angle is equal to this angle, and the sum of this angle and this angle is 90 because the right angle is 90 already. That means this plus this, which is 90, if you divide 90 by 2, you get the angle of each of them, which is 45. And that is why I have told you that the base angle of a right-angled isosceles triangle is always 45 degrees. So all these angles are 45 degrees. This one also is 45 degrees. Even this is 45 degrees. Because they are the base angles of an isosceles triangle. Now come to see it. If the whole of this angle is supposed to be 360, angle at a point. If we should extend this way, the whole of the angle is 360. We call it angle at a point or angle of a circle. Now already you have discovered that 45 plus 45 gives only this part. That means the other part is going to be 360. The angle of all of them minus this plus this, which is 90. So our theta, or the value we are going to substitute for theta here, is going to be, our arc length is going to be 360 minus 90, then divided by 360 times 2 all over 1 times 22 all over 7, which is pi, times r. They say that the circle is of diameter 4. That means the radius is 2. So we have 2 all over 1. Let's use our calculator and multiply out. First of all, 360 minus 90 will give us 270. We have 270 now times 2. We're multiplying out the whole numerators times 22 times 2. Then all over 360 times 7, which is 2520. I told you to memorize this. 23,760 divided by 2520. 360 times 7, giving us 9.4286 meters in 4 decimal places, and that is the perimeter of ALB that the question has asked in part B. Question number 4 says that the doorway, this structure is the structure of a door, maybe the door of a church because of this arc. It's made up of an arc, yes, an arc, ABC, ABC, which is 1/4 of a circle. That means the angle it sustains to the center is 360 divided by 4, which is 90. That's what they mean by it is 1/4 of a circle. That circle of radius, 2 meters. And that was why they put 2 meters here, because this is the center of the circle of which this arc is part of. The side frames are of height 3 meters. The frame of the door, 3 meters, 3 meters each. And the base is DE. The base of the door is DE. When I have to calculate the perimeter of the doorway in terms of pi and root 2. In terms of pi and root 2 means don't simplify pi and root 2. Give your answer bearing pi and root 2. Don't simplify them. That's what it means. B, the area of the doorway in terms of same pi and root 2. Let's take question number A from here. The perimeter of the doorway is the length of the arc plus the length of CE, ED, and DA. The length of the arc ABC plus the length of this side CE plus the length of this side ED, then plus the length of this side DA. So first of all, let's calculate the length of this arc. Arc ABC will be calculated by, you know, the formula theta over 360 times 2 pi r. This theta is 90 degrees because the arc is 1/4 of a circle. The angle of the circle is 360. 1/4 of 360 is 90. That means our arc is going to be 90 all over 360 times 2 times pi times r. The radius of the circle is 2. So we have also 2. Don't write this pi, or don't substitute the value of pi, which is 22/7, so that you'll be able to give the answer in terms of pi as the question has required of you. Students used to go astray in this case. They'll be given the answer after simplifying pi, whereas the examiner said you should give the answer in terms of pi. Now let's multiply out. We have 4. 2 times 2 is 4. 4 times 90 is 360. So we're going to have 360 times pi divided by 360. You can cancel this and cancel this. You find out that the arc length, arc ABC, has the length of pi. That's what it means. Now you have discovered the length of the arc. The perimeter of the doorway is length of the arc ABC plus this side CE plus this side ED plus this side DA is equal to perimeter of the doorway. Now what we're going to do now is, we know CE, we know DA, but we don't know DE. But by virtue of the structure ACED is a rectangle where AC has the same length with DE, because the opposite sides of a rectangle are equal to themselves. So we are going to calculate AC. Whatever the value of AC is the same thing with the value of AD. How do we calculate the value of AC? Our AC squared. AC here is the hypotenuse of this right angle triangle. And in Pythagoras theorem, the square of the hypotenuse is equal to the square of the other sides of the right angled triangle. So that's why I'm writing that AC, which is the hypotenuse of the right angle triangle, is equal to OAO or OA, whichever one, squared plus OC squared. OA is already 2 meters given, and OC is 2 meters given. That means our AC squared is equal to 2 squared plus 2 squared. Our AC squared is giving us 4 plus 4, which is 8. Our AC, then only AC now is going to be the square root of 8. You know that 4 plus 4 is 8. We're going to continue here. Now, remember, the question said we should give our answer in terms of pi and root 2. What we're going to do now is try to transform the root of 8 to a figure that we have root of 2. Root of 8 is something as root of 4 times 2. 4 is a perfect square. It has a whole number that is its square root. That means, and that number is 2. Root of 4 times 2 is something as 2, which is the root of 4, then root 2. That means our AC, this side, which is the same thing as ED, has the value of 2 root 2 meters. Remember, this one is pi meters. Now we can calculate the perimeter of that doorway by saying ABC, which we have calculated to be pi, plus CE, which is given 3 meters, plus DE or ED, which is the same thing as AC that we have calculated here, to be 2 root 2. So we have plus 2 root 2. Then plus ED, sorry, we have ED is something with AC. Okay, then the next one is DA. DA, which is also 3 meters. So we have plus 3. Whatever you have here is in meters. So this is going to give us 3 plus 3, 6. 6 pi 2 root 2. Sorry, they are not multiplying themselves. It's going to give us pi plus 6 plus 2 root 2 meters. That is the correct way to represent it. And that has answered question number A of that question number 4. Question number B said we should find or calculate the area of the doorway in terms of the same pi and root 2. Area of this structure now, which is the doorway, is equal to area of this arc ABC plus area of the rectangle ACED. Area of doorway is equal to area of arc ABC plus area of rectangle ACED. I'm just trying to manage our space. Now, first of all, the area of the arc ABC. Area of this arc is the area of the sector OCBC minus the area of this triangle ACO. Let me repeat myself. The area of this arc that you see here, which is ABC, is equal to the area of the whole sector. The sector OCBA minus the area of this triangle ACO. Let me write it. Area of arc ABC is equal to area of sector the whole of this sector OCBA then minus area of triangle ACO. And that is exactly what we're going to calculate now. Area of ABC you know that this ABC is the arc. It's going to be calculated by the area of the sector. It will be given by theta over 360 times pi arrow squared. That is the formula for the area of that sector. Then minus area of this triangle. There are two ways to find area of a triangle. If the height of the triangle is clearly shown, you can use half base times height for the area of the triangle. But when the height of the triangle is not available, the value of the height of the triangle is not available, you go by half times two sides, the product of two sides of the triangle, times the sine of the angle made by the two sides. Just as you have here, half times this side AC of the triangle times this side CO of the triangle, then times the sine of this angle will give you the area of this triangle. And that's what we're going to adopt, because we are not given the height of this triangle, or this information, the information in this triangle did not envelope the height of the triangle. So we're going to use that formula of half of this side AC, which we calculated to be 2√2 in equation number A. You can rewind your DVD to get back to it. That value, 2√2, which is the value of AC that we calculated, times this CO, which is 2, times half. Then multiply it to the sine of the angle here. Remember, this is a right-angled isosceles triangle. These base angles are 45 degrees each. Because they are the base angles of an isosceles right-angled triangle. So, this triangle now, which we need the area to subtract from the area of this sector to be able to get the area of the arc, will be given by half times this side, which we calculated AC to be 2√2, times this side, or this side, which is 2, then times the sine of 45, sine 45 degrees, to give us the area of this triangle ACO. So let's go ahead. What we have here now is theta. This theta is 90 degrees. The angle, the arc of the sector sustained to the center of the circle, which has been given by this block. And even from the equation, they told us that it is 1/4 of a circle. So we have 90 times pi. Remember, you don't simplify pi because your answer must be in terms of pi. Times the radius, which is half of, sorry, the radius given is 2 squared now, all over 360. Then minus 1, this one, times 2√2 times 2, then times sine 45. All over 2. You know that 2x squared means 2 times 2. And 2 times 2 is 4. 4 times 90 is 360. So in the numerator there we have 360 times pi will give you 360 pi. All over 360. Then minus 1 times 2 is 2. 2 times 2√2 will give you 4√2 times sine 45 in short form has the same value as 1 all over √2. Since the question is drawing your E here, that should give you answers in terms of pi and √2. Try to change any term that is possible to be changed and be related to √2. Try to change and relate them to √2. Sine 45 has the value of 1 all over √2. Then the whole thing divided by 2. You can divide out this. You have 2. 360 can divide 360. You'll be left with pi only here. Minus. What we have here is 2√2 2 root 2 all over root 2. That's the meaning of this. You can cancel root 2 and cancel root 2. You'll be left with 2. So the value we have now is pi minus 2. What we calculated now to be pi minus 2 is the area of this segment A, B, C, which we calculated as the area of the sector minus area of the triangle. And that's exactly what we have gotten here. Then if you add it to the area of the rectangle, which is 3 times this side AC, which we calculated to be 2 root 2 in our previous questions. So if you put together this, it will be in meters squared. That will give you the area of that doorway. 2 times 3 is 6. So this will now give us pi minus 2 plus 6 root 2 meters squared is the area of that doorway. And that has brought us to the end of that question number 4.